In this video, we're going to talk about how to calculate the equation of a line that's parallel to another line, two straight lines specifically, right? And I have put a line on your screen, which essentially says if two straight lines are parallel, then their gradients are equal because, remember we said gradient is equal to steepness. So if I put this line, right, and then I have another line that's like this, and let's pretend that this is perfectly parallel, they have the same steepness, which means if I was to hike on this line and if I were to hike on this line, right, I'm basically doing exactly the same amount of work. So the gradient of this line is equal to the gradient of that line as well. Their gradients are equal. Why is this important? Because remember, when we said when we want to calculate the equation of a line, y is equal to mx plus c. The critical thing that we always need is going to be the gradient, the m value, right? Once we find the m, once we're given the m, a lot of the work has really been done. Now all we need from that point is one point that we can plug it into the formula and then calculate what the c value would be, right? So that's the step that we just need to, that we need in this case, right? So we need to be able to relate the gradient to a given line. So let's just say, for example, if I tell you that this line's gradient is equal to 1, but I tell you the point on this other line, you can actually already calculate the equation of this line because you already know that this gradient is also equal to 1. So all you'd need from that point is to take the point that you've been given, plug it into this formula, and then you have your answer for the equation, right? So essentially that's what we're going to do, right? So let us go through a question. Example 1, we're going to go through a couple of questions actually. So I tell you that a line, we have a line that passes through, let me say line A passes through points, passes through the origin and a second point, which is going to be -2 and 3. Right? Find the equation of line B, which is parallel to A, which passes through the point 3 and -1. Okay, cool. So you're given 2 points, right? And essentially what you need to do is what we're being asked to do in this question is to calculate y is equal to mx plus c for line B, right? We need to calculate the equation of line B, which means for line B, we need to figure out what the gradient is. And then once we get the gradient, we can calculate what the c is. But we're only given 1 point on this line. So how are we supposed to know what the gradient is? In order for us to calculate the gradient, we can use this piece of information that we're given over here. The fact that the two lines are parallel. It's parallel to line A. The fact that it's parallel to line A, this tells us that their gradients are equal. So if I have enough information from line A to calculate its gradient, I can just use that gradient for line B as well because their gradients are equal, right? Hopefully that makes sense. So that's what we're going to do. We are going to come back here and say, okay, we need to calculate the gradient of A. The gradient of A, how do you calculate gradient? We say it's y2 minus y1 divided by x2 minus x1. Okay, so putting this into the formula, right, we can say our point 2 is going to be this point over here, which means this point is going to be our y2. This over here is our y1. X1, sorry. X2. Sorry about that. Okay, so that means in the equation, it's going to be y2, which is 3 minus the first y value. If you're told origin, it means it passes through 0 and 0. So this means that this is 3 minus 0, and at the bottom we have -2 minus 0. Okay, so -3 minus 0 is 3, -2 minus 0 is -2, 3 divided by -2, so you should get -3 over 2 if you put that into your calculator. Okay, so that's the gradient of A. But we also know that this is equal to the gradient of B because the two lines are parallel. So now we can just take this value as is, put it into the y is equal to mx plus c equation of B, right? Mx plus c equation of B is equal to y is equal to negative 3 over 2x plus c, right? Which now at this point, how you then calculate the y is equal to m, how you then calculate the c is you say, okay, I need a point, right? The point that we've been given is 3 and negative 1. So at 3 and negative 1, our equation becomes, so we can substitute that into our formula, right? Your x value, your y value is negative 1. So that's negative 3 over 2 multiplied by x. Your x value is 3, right? And then that's going to be plus c. So this is equal to negative 1. 3 times 3 is 9. 9 over 2. Well, that's supposed to be negative. Yes, it was. Negative 9 over 2, and then that's plus c. You're going to take that to that side, and it's going to become negative 1 plus 9 over 2, which is equal to, I think that should be 7 over 2. Yes, it is. That's c. So c is equal to 7 over 2. Right, which means plugging back into our equation, right? So this becomes y is equal to your gradient, which is negative 3 over 2, x plus your c value, which is 7 over 2. You can write this, right? If you don't want the denominators, you can multiply everything by 2, which means this equation becomes 2y is equal to negative 3, because these 2's cancelled, negative 3x plus 7, right? So you can write this in different forms, right? If you wanted to use a different method over here, which is that other method, I'm going to try to do this as quickly as possible. There's a method where we said we can use x minus x1 is equal to y minus y1, because this is the method that we use when you have a gradient and a point. So your gradient is going to be negative 3 over 2 multiplied by x minus the x point of your point, the x value of your point, which is 3. And then this is equal to y minus the y value of your point, which is negative 1. Y minus negative 1. So quickly to simplify this, this becomes negative 3 times x. Negative 3 over 2 times negative 3 gives you positive 9 over 2. That's equal to y plus 1, because negative 1 times negative 1. Then two negatives make the positive. So to make y the subject of the formula, you're still going to get negative 3x over 2 plus 9 over 2 minus 1, that's equal to y. Therefore, your y is equal to negative 3x over 2 plus 7 over 2. Right, so it always gives you exactly the same answer, or whichever method you want to use. So you can just make that decision on your own. So yeah, that is the first example, right? So that's the thing that we just need to emphasize. Even though you don't have information on this line over here, because you have enough information on this to get gradient, the gradient is transferable between the two lines since they are parallel. Okay, let's just use one more equation, one more example, just to drive home the point. This is going to be example 2. In example 2, you're given that you have line A, which has equation 2y minus x, which is equal to 5. Right? And you're also told that line B passes through the point 3 and 4. Find the equation of line B, right? Which it's exactly the same as what we said before, right? Where we said, okay, all we need to do is say, okay, y is equal to mx plus c. This is for line B, right? We're calculating y is equal to mx plus c of that line, right? All we need is, number one, we need the point, right? Which we have. Perfect. This is cool, right? We have the point. We also need the gradient, right? How do we calculate the gradient? We can calculate the gradient by looking at line A because, oh, sorry, forgot to say lines A and B are parallel. All right. So let's just put that piece of information somewhere. Let's just do this. I'm busy rushing. All right. Just take this. Let's take this back there. And then we're going to say lines A and B are parallel. Okay. Oh my goodness. Okay, lines A and B are parallel. This tells us that as long as we know the gradient of this line, right, this is going to be the gradient of A, but it's also going to be the gradient of the line B because the two lines are parallel, their gradients are equal. So even though we don't have enough information on this line to calculate the gradient, we can just use the information on the first line, line A. Okay, so what is the gradient of line A? All right, so let's come back here. The gradient of line A is equal to, right? How do you calculate that? Because we already have the equation, which is 2y minus x is equal to 5, right? Usually, when we're already given the graph as is, right? When we already have the equation, we can actually just look at the graph, right? We can look at the equation because it should follow y is equal to mx plus c. But in order for us to directly interpret what the equation is, what the gradient is, we need to make sure it's in this format over here, right? So we can't do it unless we make y the subject of the formula. So in order to do that, we're going to make this 2y is equal to, I'm going to take the x to the other side, and it becomes positive x plus 5. All right. When it's positive x plus 5, then again, even if you were given the form in this, the equation in this form, be careful to say, okay, this is a 1, then my gradient is 1. We need to make sure that this y is on its own. So if y is being multiplied by something, you need to remove that thing it's being multiplied by because it has to be in the form y is equal to something. So your y has to be isolated. So in this case, we're going to say, okay, divide everything by 2 to get rid of the 2 that's on that side. So that's going to become y, since the 2's cancel, is equal to half of x plus 5 over 2. Now in this form, now we can interpret directly what the m is, because this is y is equal to half multiplied by x plus 5 over 2. So here we can clearly see that the gradient is a half. The c is 5 over 2. Okay, so now we know that the gradient of A, which I'm going to write as MA, is equal to a half. And that's also going to be the gradient of B as well, because the two lines are parallel, their gradients are equal. All right, so now we can say, okay, going back to y is equal to mx plus c for line B, we now know that our m is a half. And I need to apologize here because I've actually gone through the whole question and I realized that I put the point that's on the same line as here. So I'm going to change this point to 3 and 3. So hopefully that's not too much of a problem. So this point's going to be, the point on line B is going to be 3 and 3. Okay, so what we're saying is, we're saying at the point at 3 and 3, we now have y, right? So we're basically plugging in these coordinates. Your y value is now 3. Your m value is a half, as we saw over there. Your x value is 3. And then you're going to add your c value. So this is going to be 3 is equal to 3 over 2 plus c. Therefore, the c value is going to be 3 minus 3 over 2, which is 3 over 2. So your c value for this equation is going to be 3 over 2. Therefore, the equation of line B is y is equal to your m value, which is a half of x, plus your c value, which is 3 over 2. If, again, you wanted to write this as, if you don't want to include denominators, you can multiply everything by the common denominator, which is 2. So this becomes 2y. All right, that's 2y is equal to 1 times x, which is x plus 3. And that is your final answer. Hopefully that makes sense, right? All you need to know from this video, right? So the conclusion is that first line that I put here. If two straight lines are parallel, then the gradients are equal. So if I don't give you enough information on one line, but I give you enough information on the other, and you know that they're parallel, take the gradient of the one that you know enough about, and then apply that gradient to the second line. And essentially that's how we're going to apply this rule. Okay, so we'll look at more complex questions as we do exam problems, but for now, this is where we'll stop. I hope this made sense, and I'll see you in the next video.